Hello, General Math. Sorry I couldn't be there in class today. Note the things you're going to need today. You're going to need a pencil or some form of writing utensil, some notes, your practice semester test. So if some of you have left it in my classroom, it's in the bin. You know where to pick it up. You also need your protractor for measuring angles today. So make sure you have that. I believe you will not need a calculator today. Unless you're going to do a couple of examples I'm going to do here in the beginning. Goals: do a couple of review problems from section 7475, which are based on the polygons and doing perimeter and area and volume. We'll do those. We started those the last couple days, so we're going to kind of review that. And then the goals today are to go through your practice semester test and go through the next 3 problems. We voted yesterday to do 2. Today we're doing 3, and then Monday we'll finish with the last 3. Semester test for you guys is on Monday, so keep that in mind. Semester test is on Tuesday. Tuesday. Monday we'll have book check-ins. You need to bring your textbook Monday, and we'll check them in class. Semester practice guides are due on Tuesday when we take our semester test. You always get 2 days to do that. You get to use a calculator, so don't worry about that. But that's pretty much about it. You'll get a protractor and you get a ruler. Those are the only things you'll need. But today, we're going to go through a couple problems, then we'll get to our practice semester test. All right, let's hop right in. So let's take out your notes first. All right, so I have 3 problems on this piece of paper here. The first one is going to review perimeter. So what we've talked about with perimeter is how to find perimeter. Perimeter is the distance around an object. So it's actually going this distance around this picture, and what you do is you add up the walls themselves. So as you can see here, to find perimeter, you just add 3 plus 5 plus 6 plus 4, and they get the total of 18, and that's perimeter. That's how you find the distance around an object. It's pretty easy. We did that the other day with a quad as well. So that's my example. Now for area, this is the one we just started yesterday. So Sam, if you were gone yesterday, this is the problem we did in class. I think we did it with a little piece of grid paper. So the other 2 gentlemen were helping calculate some of this. So how you find area of a problem, let me switch colors here. Area is how many little square tiles are on the surface of your picture. That is area. Okay? So what you do is the easiest way to do this, other than, adding up all the boxes, is you take your 2 numbers that you have in this picture. So you take the 12.6 and you multiply it, so that's the length, and you multiply it by the width, which is the 6.4. And what that does, it doesn't matter if they're decimals or if they're whole numbers, that gives you the total number of boxes in an object. And that's what we did yesterday with the grid paper. We took the width and the length, which were really kind of bigger numbers, and we multiply them together. So if you have a calculator and you actually take 12.6 and we multiply by 6.4, we're going to get 80.64 if you actually multiply those together. And what that stands for, this is the area. So that is the number of square units, square tiles, or square centimeters in an object. So that's these little squares here. There should be about 81 little square tiles. That's area. So in this room, if you're looking at the floor itself, there's tiles on the floor. Well, we could guesstimate how many tiles are on the floor by taking the width of the room by the length of the room. Now, I did these calculations years ago with some other classes. There's about 1,200 tiles on the floor of my own classroom. There's a lot. I mean, it's a big classroom. And why that's important, like what we use area for, is area helps you figure out, if you had to retile the floor, how many tiles you're going to need, or carpet, how much the carpet would be to replace it. It also helps you figure out if you're going to paint the walls, how much paint to use, and how much you're going to need to purchase. So those numbers are insanely important. Now, perimeter, on the other hand, the one we did earlier, that's if we were to put up a new fence in our backyard, right? You'd have to figure out how much fencing to put up, or if you're on a farm, maybe. So that's kind of the idea. So those are the 2 purposes. Now, the last one that we have not discussed, that I hinted at that we were going to do today, was called volume. Volume is 3-dimensional. So as you're looking at this picture, it's a 3-dimensional little block. What we're trying to imagine that is like a barn, right? It's a terrible looking barn, but let's say it's a barn, and we're trying to figure out how many actual square bales, like cubes, you could fit in that barn. So actually drawing these little cubes in here, it's how many of those you could actually fit, stacking them all up on the inside of this object. Okay, there's a lot. But how you find it, it's a very easy number. Basically what you do is you find the area of the top of the box or bottom of the box. So in this case, we're going to do the bottom of the box here. We find the area of it, taking 4 times 5. And then what you do is you just take it times how tall the object is. So it's length times width times height. And that gives you volume of a picture. So if I take 4 times 5 times 10, 4 times 5 is 20. And we take that times 10, which is 200. And 200, that is cubic. And I guess on this picture is meters. So if we're thinking about bales, there's 200 bales that could fit in that barn before it's full. You know, in my classroom, the practical application is how many desks could I stack in my classroom, like from floor to ceiling, from the front of the room to the back of the room. Now, if you're looking at my classroom right now, there's 29 desks in there. There's quite a few. But imagine that you're trying to fill the room with them, where there's no other room to put them. Now, I know that desks are tough because there's a lot of gaps in desks and they could stack and they can kind of fit together and fold together. But I'm talking about if they were solid, like cubes, bricks, how many could fit? There's quite a few. So in this room, I already have 29. You could maybe imagine that there could be maybe 7, 8 times that could fit before it's full. I don't know. So it's one of those things we might look at Monday to do calculations, see how many work. But again, that's volume, that's area, and that's perimeter. Hopefully those 3 things make sense. Now the new one again is the volume. So make note of the formula, length times width times height. But again, that's for what they call a rectangular prism, right? A 3-dimensional box. All right, let's move on to your practice semester test. Hopefully those 3 problems made sense to you. Okay, practice semester test. So if you have that out in front of you, if you need to pause the video and go get them from the basket, you can. We're going to look at problems 6, 7, and 8 today. 3 problems. Hopefully this is pretty easy for you. The first one requires that you have your protractor. So if you want to take out the protractor now, it's that clear piece of paper, the film that had our protractor on it, the little measuring tool that we use to measure angles. You're going to need to put that on your paper. And what we're going to try to do here on this problem is we're going to try to draw the angle that I'm asking you for. So on this problem, if you're looking, I'm trying to ask you to draw a 145-degree angle. That is an obtuse angle, right? It's a big angle. It's obtuse. So what I'd like you to do first, before you even put your protractor down, you need to draw a line on your paper. And then we'll put the protractor on it so we can actually measure where the line's going to go. So I'm gonna draw my line here. So this is my line. I'm going to put a little dot on it. And what I'm going to try to do is I'm going to try to draw the angle going this way, opening up to where I think 145 degrees is going to be. It's going to be something like that, right? That's going to be 145 degrees. But I don't want you just to guess where it's going to be. We're going to actually put the protractor on your paper and measure it perfectly. So let me get rid of all that. All right, so let me throw the protractor that we have on paper. Here it is. That's pretty. All right. Oh, it just went away. I didn't really think that one through. I'm going to have to actually wait. I wonder if I can review that. Nope, we're going to have to grab another one. Didn't think that one through. Alright. So, to draw on this object, so what you're going to want to do is draw the first line, start at the center of your protractor and go out. Now, I know that the plastic kind of gets in the way, so just draw a line on your paper, then put the protractor on it. So you want to line up the dot and where the 180 degrees is. Once you have that perfectly lined up, and again, don't have that little space like I have. I'm just trying to show you where it needs to go. Then what you're going to do is you're going to count up. This is 0, and you're going to count up using the inside track. Again, we're drawing this in what they call standard positions, so that the angles have to face the same direction. We're going to open up, so we're going past 90. Again, I'm using the inner track numbers, and we're going up to 145. So right now I'm up to 140. This is 145 right there, because again, this is the mark for 145. What you want to do is, if the plastic's getting in the way, I want you to hold the pencil where you think 145 is, and then just move the protractor away. So if you move the protractor away, you'll be able to draw on your paper, and then just draw that final line. It should be really close. Again, use a straight edge. I have some rulers over there by the cabinet, so you can always grab one of those if you want to draw really, really accurate lines. But this is what I'm looking for. This is a 145-degree angle. That's what I'm looking for. I'm looking for accuracy, especially on test day. I'm looking to see how close can you get to that exact angle. I'm going to give you about 1 to 2 degrees leeway, but that's not a lot. You have to be very accurate. So again, to practice, if you need to rewatch that video, you can. But again, you're putting the protractor on paper and trying to draw the angle that I'm giving you. Okay? Hopefully that makes sense. Let's move on to the next problem, number 7. Number 7, we need to measure this object with a ruler. So again, if you borrowed a ruler earlier for the protractor problem, if you didn't, you need to go grab one. They're over by the cabinetry again, by where you have your practice guides. We're going to measure this object, this little stick, with your ruler. It needs to be with this metric system. So I'm going to put a ruler on my paper here. So now, again, this will not be as accurate as yours because, again, my picture is a little bit different than yours. But let's bring this up. All right. So if you're lining this up, again, the trick is I want you to line up 0. So 0 is lined up correctly. Now, again, your numbers are different than mine because this is not drawn to scale. But you're going to line up your ruler with the metric system. It should say, centimeters at the top. Don't use the inches side. And then count up until you get to your final mark. Well, this for me is almost exactly, this is my picture, not yours, but mine is almost exactly 12 centimeters, right? Now, if it went past that, maybe it made it to the first marker here. Fine, that's 12 centimeters, 1 millimeter. But again, how you write that as 12.1 centimeters. Whatever this number is, that's the decimal that you put back behind it. So if we were measuring and maybe the stick goes to here instead, maybe that's where your stick landed. Well, that would be 5 centimeters. And we went, 3 hash marks in, so that would be 3 millimeters. So that would be 5.3 centimeters if you write it as a decimal. The metric system is super easy. All right, does that make sense? Now again, my picture is different than yours because obviously my ruler is not accurate. I just picked a random picture from the internet and I threw it on top of this. But again, I want you to be accurate, be within 1 hash mark. Don't just say, oh, it's about 12, 12.2, 12.3. You have to be super accurate on which number it's hitting. So look at your ruler very, very closely. Okay, let's move to the next one. Last problem of the day. I want you to find the perimeter of this polygon. Now this polygon is a quad. It's a 4-sided figure. Again, I'm going to give you a random picture for the semester test, but I'll ask you to find the perimeter of it. The big thing here is making sure they're in the right measurement. So one of these is not. So if you're looking at this picture, this is in millimeters. So we're going to have to change that. So if that's 27 millimeters, that means 2.7 centimeters. Again, on test day, I'll kind of help you out if the picture isn't drawn to scale. I probably won't do that to you, but if you need to, we'll try to fix that. All right. What we're going to do here is we're going to try to add these numbers together. Okay? So we're going to take and we're going to add the top wall, which is the 2.7 centimeters. We're going to add that to the other wall, which is 3.4 centimeters. We're going to add that to the 2.1 centimeters. We're going to add that to the 3 centimeters. So adding those 4 numbers together, that should give me the final perimeter. So if you have a calculator, you can add these numbers up. So 2.7 plus 3.4 plus 2.1 plus 3. This should be 11.2 centimeters. That's what I'm going to expect you to do on semester test day. Now again, remember, your goal today is to fill these out. Don't just leave them blank. I am checking this practice test, so you should be filling in answers as we go. If you didn't, go back and fix them. Go find the answers again. You can go on my website, mrward.org. Find today's video. It should be, if you scroll down the page, it should be there for general math. But if you need to, review the video, rewind it, play it again. I'll make sure it's online. I'm going to go back this week because I took all the other videos offline to make it easier for you to find this one. I'll put all the other videos online so you can go back and check the other days that we did for the review, so we can see the the problems 1 through 4, 1 through 5, I should say. But the goal on Monday is to finish this practice guide, which is 9 through 11. And then semester test is on Tuesday. Book check-in is Monday. Bring your textbooks. So we'll check them in. All right. Have a great weekend. Use your time wisely today. Work on wherever you need to. Get it done. And I'll see you on Monday. Goodbye.